This video is about solving two variable systems by elimination. So last time we talked about solving two variable systems by substitution, which is not my favorite method. I prefer this way. So what we're going to be doing this one is using our multiplication skills to help us get rid of things we don't want. The basic steps are: number one, decide which variable we want to eliminate. Number two, multiply one or both equations by some constant or constants so that adding or subtracting the equations will eliminate the variable. And number three is solve the systems using the elimination method. So without further ado, let's get started. So let's look at this problem. To me, the first thing that I see is there's nothing I can multiply by 2 to get me a 3, and nothing I can multiply by 3 to get me a 2. I could use these, but it would take a bunch of work. If we look at the bottom equation, though, if I multiply 2 times 4, I get -8, and these will cancel. So that's what I'm going to do. So the way that I do this is to help myself keep organized. I write an arrow like this to say kind of what I'm doing here. So this one I'm keeping 3x plus 8y equals 7, right? This bottom one, what I'm going to say is I'm going to multiply times, I'm going to put my dot, times 4. So 2 times 4 is going to be 8x. -2 times 4 will be -8y, and then 4 times -10 will be -40. From here, I'm just going to add, and I mean add down. And when I do that, I'm going to put a plus here. I'm going to circle it just so that I know it's not a sign or anything. It's a reminder that that's my operator. So that's 8, 9, 10, 11x. Okay. The plus 8y and the minus 8y, those two guys cancel out. And then over here, I have 7 plus -40, which will give me -33. And as you can see, now this really isn't too bad. I'm just going to divide by my coefficient 11, and I get that x equals -3. I think that's a lot easier so far. So I'm going to take this, I'm going to plug it into either problem. I'm going to go with the bottom one because the numbers are smaller and I'm lazy. So 2 times my x was -3 minus 2y equals -10. So 2 times -3 will be -6 minus 2y equals -10. I'm going to add 6 to both sides. These guys cancel. -2y equals, let's see, -4. Divide by -2. And we get that y equals 2. So my solution as a coordinate, x comma y, will be -3 and 2. So to me, this is an easier method than substitution. I think it goes a little faster, but, hey, I guess that's your decision to make. So let me scroll down, do another example. Let's see if I can make this one work out nicely. So here we've got a slight problem. I can't multiply any single thing and make these balance each other out. So what I'm going to do is a bit of a trick. My plan is this. I'm going to multiply the top one by 4 and the bottom one by 3. You can see where the 3 and the 4 came from, and I just reversed them. So let's see how this plays out. So -3 times 4 would be -12x. 4 times 2 will be 8y, and then 4 times 4, will be 16. On the bottom one, 3 times 4 will be 12x. 3 times -13, let's see here. 13 times 3 is 39. -39y, and then 5 times 3 is 15. And again, I'm adding these. So, -12 plus 12, those cancel out. We have 8 plus -39, which is the same as 39 minus 8, and we're just going to make it a negative, so it'll be -31y. And then 16 plus 15, were you freaking out? Because I wasn't, equals 31. We'll just divide by negative 31, and we get that y equals negative 1. We can plug that into either equation. I think the top one looks easier this time because it's got the smaller numbers. Negative 3x plus 2, and this time we had a y, and that's a negative 1, equals 4. So that's negative 3x minus 2 equals 4. Add my 2 to both sides. Negative 3x equals 6. We'll divide by that coefficient of negative 3, and we'll get that x equals negative 2. Put our answer back in a coordinate, x comma y, negative 2, comma 1. And there we go. It started to look a little bit scary here with a 39 and the 15, but they usually work out a lot better than you think they're gonna. So let's take a look at this last one. This one looks like it'll actually be significantly less work than the previous one. Thank goodness. I always like doing less work when possible. I'm going to leave the top one alone. I'm going to multiply the bottom one by negative 4 so that the y's cancel out. So this one is going to stay the way it is. Negative 3x plus 4y equals 12. This one I said I'm going to multiply by negative 4. So negative 4 times negative 2 is negative 8x. Negative 4 times 1 will be negative 4y. And negative 4 times negative 8 will be positive 32. So we're going to add. That's negative 8, 9, 10, 11. So negative 11x. The y's cancel out. And then 32 plus 12 is going to be 44. We will divide by negative 11. And we will get that x equals, negative 4. Okay, we're going to plug that in. I think the bottom equation looks like it's less work. It's got smaller numbers, less numbers, etc. So let's go with that. 2 times, and our x was negative 4. Oops. Keep with my color convention. Plus y equals negative 8. Okay, 2 times negative 4 will be negative 8 plus y equals negative 8. I'm going to add 8 to both sides. And it looks to me like y equals 0. So here we go. As a coordinate, x comma y, our solution is negative 4 comma 0. And there we go. So this is the logic that we use when we are doing solving systems by elimination. We ideally prefer it when it's something like this problem, but sometimes when you have something that doesn't exactly match, like that second example, you have to kind of multiply this way in order to get rid of things and make it more convenient for you.